We have new and improved options for handling errors in SQL 2005 and beyond. Let's look at the grant table for an example. And here we've got grant number 1, which is 92% team. It's employee 7 who found it, and it's a small $4,750 grant. Well, that's kind of a cute name, but let's say we didn't quite get it right, and they want us to update the name to the more proper name. So we're going to set the grant name in the grant table to 92% team, where the grant ID is equal to 001. This should run just fine. Right data type, everything looks good. One row affected. Great. Well, this next statement is going to throw an error because the grant name is a required field, so I can't set it to null. I'm going to attempt to set grant number 1 to null, and let's see what happens. All right, a big blasting error. You can't insert a null value into the grant name field. Now what we're going to do is we're going to do what's known as structured error handling. We've got some code that we know is vulnerable. It'll work most of the time, except for when an invalid value is sent there. And sometimes you can't stop the client from doing that. But what we do want to do is we want to stop the error message, or at least control what it says. So let's do this. Let's go begin try and end try. Now, what are you going to do between a begin try and an end try? The code you want to run that you know is occasionally vulnerable to making an error. And if it makes an error, you have a contingency plan known as a catch block. So you're going to put all of the code you want to run instead of the error message in the catch block. So let's do this. Let's write the update statement that updates the grant and sets the name properly, where grant ID is equal to 001. And in the catch block, we're going to put no change was made. That's pretty good, isn't it? If the update statement in the try block were to fail, then the catch would run. But if the try succeeds, then the catch block doesn't run at all. Only one of these two will run. Think of the catch block as plan B. So if we highlight all of this code, we know the try is going to run successfully. It just says one row affected. The print statement in the catch block never ran. Now, let's put in a situation where the try is not going to run. Let's change this to null and execute all your code. If you run the update statement by itself, we're going to see a big error message. But what happens if we run it using structured error handling? The try failed, an error was created, but the handling was passed to the catch, and instead of raising the error, you raised everything you see in the catch, and it just says no change was made. It's time for a quick lesson on the options of the try and the catch block and when they run. Does the catch always run if an error is raised in the try? And yeah, that's pretty much true, but there are some raised errors that won't cause it to go. Let's start off with one that does. Let's put an error inside the try. This is one we're sure is going to raise an error. We'll call it bad stuff, severity 16, and it has a state of 1. And what we're going to do when it gets an error is we're going to print catch ran. Okay, let's run this. Notice it says catch ran. It doesn't even say what the error message was, but if you want, we can show that. You can say print error underscore message paren. Now let's run it. It says catch ran, and the error was bad stuff. Oh, but I don't know the severity level. So let me put print error underscore severity paren. Let's run this and see what it says. Catch run bad stuff 16. Very good. Okay, let's change it so that the severity is 11. And we'll call it sort of bad stuff. Is that enough to trigger the catch? Sure enough, it says catch ran, sort of bad stuff, severity 11. Severity 11 was high enough to run the catch block. Okay, let's change it to 10, and we'll say the error message is trivial stuff. We can test this by running all of the code at once. Severity 10 wasn't high enough to run the catch block. The only statement that ran was the raise error. The try executed, and the catch never ran. That's because the try only hands over execution to the catch if the severity is 11 or higher. If it's 10 or lower, the catch doesn't fire off. Remember this stored procedure that had a little trouble with its different types of error actions based on what was going on? Sometimes the second update statement would run even after the error in the first update statement, and sometimes it wouldn't. Well, let's test it out. Let's execute the add grant amount for grant number 3, and let's pass it a null. The first statement failed because you can't pass a null into that field, but the second statement updated the timestamp, saying I got you updated for that employee record. That's not a desired result, but let's go ahead and run the perfect scenario first. Call the stored procedure and pass it 2 valid parameters, just to see, under ideal conditions, we get 1 row increased in the grant table and 1 row updated in the employee table. Well, if we want these to succeed or fail as a whole, we've learned a long time ago that we can put a begin tran at the beginning and a commit tran at the end. Run your alter procedure statement. Now, did this protect us? The problem being, it can get to the commit trans statement because transactions ignore the raise error. So here's what we want to do. We want to put begin tran and commit tran in a try. If there's any error in here, cease operations and run what is ever in the catch block. So what will I put in the catch block? Well, roll back the transaction. All right, that's a lot of code, so let me just select all of it, run the alter procedure statement. Now let's call on the stored procedure and watch what happens when we exercise this null. 0 rows affected. Now I would say that no records changed. Neither table has changed. Now let's call on the stored procedure and pass it a legitimate value. Hey, we have 2 updates. Now let's just verify. Let's look at all of the records from the grant table as related to grant number 3. All right, it's at $20,100. Let's look at employees 7. Let's see what their last updated time for the grant table is. Select all fields from employee where emp ID equals 7. That record has been updated. When we call on the stored procedure and pass it a null parameter, the first update encounters an error. The try block goes over the catch block, which rolls everything back. Let's see if grant 3 is still at $20,100. Yep, still $20,100. Does employee 7 still have the same timestamp? Yep, 6:02 p.m. Will both update statements inside the stored procedure run if we call on them correctly? It seems to indicate so here. Are we up to $21,100? Yes, we are. Does employee 7 have a newer timestamp than 6:02 p.m.? Yes, that value has been updated. Before turning you loose on the skill check, I need to do a quick refresher on transactions and foreign keys. Let's start off by looking at all of the products of the current products table. We have 486 such products. Some of these products have never ever been ordered. Some have been ordered multiple times. Let's find out which ones have never been ordered by doing a left join with the sales invoice detail table on the product ID being related between these 2 tables. Now, if it's never been ordered, that means it won't exist in the sales invoice detail table, and we'll look for nulls there. Product number 1, the underwater tour 1-day West Coast, has never been ordered. Product number 7 whatever it's called, that has been ordered. You know how we know? Well, it's not listed in this query. Since this is a query of all products that have never moved, anything not listed is something we have sold. So let me go ahead and delete product number 1 since nobody's using it anyway. Delete from current products where product ID equals 1. And it very happily let me do that. What happens if I try to delete product number 7? Knowing full well that there are invoice records pointing to it and depend on it for its lookup data. Well, if your foreign key is in place, it says, sorry, I can't use product 7 until all the invoices are no longer using it. Okay, now let's say the next day we get a nice big order. Somebody wants to buy a bunch of underwater tours for product number 1. So we will put that on sales invoice detail ID 6961, because that's the next one, and that'll be invoice number 1885. That'll be product number 1. They're going to buy 9 of them, and they don't even want a discount. That sounds like a pretty good order to me. Why is this going to fail? Product number 1 has been discontinued. You deleted it. Uh-oh. Okay, well, how about we delete product number 2? But just as we do that, we notice there is a customer that is ordering product number 2. So in other words, this gets us to the skill check challenge coming right up. Lab 2.1, Skill Check 1. Take the code in the figure below and put all of it into one transaction. Wrap the transaction with a set of try-catch blocks. Commit the transaction if there is no error and perform a rollback if there is an error. When you're done, check to see that no records have been deleted from the current products table, nor have any records been added to the sales invoice detail table. When you're done, your screen should resemble the figure you see here.